Hello, future engineers, and welcome to the third video on our stats. It is on making a histogram. So if you remember, a histogram shows us the frequency of the occurrence of a certain data point across a population. So if we look over here, we have got all of our data, which is going to serve as our population or our sample. And then what we're going to do is we are going to first figure out the frequency of our anomaly. So I believe that's the one that we want to do. Yeah, we're going to go for anomaly, and we're going to do this in our large bins, So what do I mean by bins? Bins is the range that we actually have to throw our data in. So for example, our anomaly goes from a range of negative 0.14 all the way up to 1. So our bins are going to be relatively small, which we are just going to divide where these fit in. So for example, if I start my bin at, I'm going to title this bins over here, and I start my bin at negative 0.2. And then I move my next bin to negative point, we're doing the large bins, which is 0.05. So then this one should be 0.05 larger, which is actually negative 0.15. The one that would be after that is going to be negative 0.10. So that's how we go through this. Now, we want to fill these all the way in until we get to our largest number. So I'm going to highlight each and every one of those, and I'm going to drag this out. You can see I now just went one above it, and that's okay. I'm going to delete that for now. We might need to add it in later. So now these are our bins, which says if the number is larger than negative 0.02, but smaller than negative 0.15, we're going to put a 1 tally mark over here. Then in our range, we move up 1. It would be negative 0.015 and negative 0.1. If there's any number that falls in between that range, we are going to throw 1 or 2 or 3, how many frequencies we have occur over there. So we could go through and say, oh, we've got an anomaly of 0.08. So where does that fall? That is larger than this number, but smaller than this number. And we go and we hit 1. Then we go over to here. Oh, we actually need to change that to 2. Then 0.09. This goes up to 3. We've got a frequency of 3 over there. Now this number is larger than this number. So we put a 1 in over here. Obviously, that is going to take way too long. We have a formula for it. It is our frequency formula. So I'm going to write frequency up here. And now I'm going to say that my frequency is equal to frequency. Our frequency is going to take 2 arguments, but there's a very specific way that we want these arguments to be filled in. The first thing that we're going to select is we're going to take all of our data, which we have already called our anon temps, and then we're going to sort it into these bins over here. So I'm going to select all of those bins, and then before I hit enter, I'm going to hit Control-Shift-Enter, and it's going to array that formula. What that means is that it's going to actually take our frequency and distribute it throughout our bins instead of just adding it to our first bin over here. If you're on your iPad and you can't hit that, you just need to type out array formula and then put the frequency in between that. I'm going to hit enter, and it sorts all of my frequency for me. It goes through and it adds where they're at inside of this range. You can see that it did 1 above, so that means that we do have to add in this 1.005, which is the next step in our bin. Perfect. So the next thing that we want to do is we want to actually find our normal distribution of this. Remember, that's our curve. We're going to see where that curve aligns in our equation. So I'm going to call this one normal distribution, or norm dist. Norm dist takes a little bit more time to calculate. So we're going to take a look at it. We'll say equals norm distribution. So norm dist. If you were to type it up here, you get to look at the formula help. So it actually takes 4 arguments. It takes our x value, that is going to be our bin where we want it to be located. It takes our mean, our standard deviation, and then it takes a Boolean function, whether or not it is true or false. Cumulative, if we want to add up all of these as we go around, which we do not in this case, so we're going to leave that as false. So the first thing that we want to do is say where we're going to place it. We're going to place it in our bins. So we're going to take our bin and I meant to click over here. So now we're going to select our bin as our first option. Now our bins, we want this to be floating, meaning that it's going to move along as it distributes our normal distribution through each of these. But what we want to have stay the same every single time is our mean and our standard deviation. So I'm going to say my bin, comma, I'm going to select my mean, and then I'm going to hit F4, function 4, which just adds these dollar signs. If you don't have a function key, that's okay. All you have to do is hit $H, $19, unless you move this around, but I would suggest not moving these tables around. So there's our mean, then we're gonna hit comma, and it's looking for standard deviation. That is down over here. So we're gonna select this. Again, we want this to be the same, consistent through each and every one. So we are going to hit F4 again. And then the last thing that it takes is that argument, true or false. Do we want this to be cumulative? We don't want it to be cumulative. We want it to be the instance at every single point so we can get our true curve. So I'm gonna hit false and then hit enter. And you can see our normal distribution has just been hit over here. We don't have it in our second box. Oh no, we have to type out that formula all over again? Nope. A real cool trick, if you hover over and you just double click on this, it's going to fill in all of our normal distributions. So here we go. We now have all of our data ready to make a graph. So I'm going to select all of this data and I'm going to say insert chart. And it gives me a line graph. That's not what we want. We want to have our combo chart. You can see that it is one of the suggested ones. It's also down here. This is going to give our frequency, our normal distribution. So let's take a look at this chart real quick and talk about it. First off, we are comparing that anomaly to our average. Where's our average? Our average is going to be 0. Remember, that's our temp. That right there is what we are basing off what our Earth's natural temperature should be. So looking at this, where's the majority of our data? Above our base temperature after a long-standing average. So this right here is showing that our Earth is warming and we are moving further and further away from our average. Cool. So we probably want to change up the name of this so we can change our chart title from frequency and normal distribution to just anomaly. But I'm also going to put this as large bins. We used very wide ranges. The next one that you're going to make has smaller bins. So anomaly large bins. That's good. I'm going to center it. Then on my horizontal axis, that is not our bins, that is actually our anomaly ranges. And then our vertical axis is going to be our frequency. There we go. And we now have a histogram of all of our data. So I am actually going to take this and copy chart, throw it into my assignment overview over here. This is our large bins. So I paste it right in the box. Nice and easy. So you have to do this with smaller bins. If you look over here, our large bin size, we did 0.05. Smaller bins, you are going to make the bins 0.01. So you're gonna have a lot of bins, and it's going to flatten the curve a little bit and give us a little bit more view as to how this data has been shifting and moving around. So that is it. Thank you for watching. I hope that you have a wonderful day. I'll talk to you soon.